All right. Well, thanks everyone for coming. I hope that this particular seminar lecture today will be something super practical that all of you will be able to use in your jobs and in your computations for your research. As we get started, just wanted to reiterate, please feel free to ask questions. This is a great venue to get some help with some tricky concepts. Feel free to unmute yourself and to ask verbally, or you can use chat. If you do ask verbally, just know that this lecture is going to be recorded and will be uploaded to YouTube. So let's dive in. So our agenda today, we're going to go over a brief introduction on what Slurm is and what it does for the supercomputer. We'll talk through batch jobs. We'll talk about interactive jobs. And then we'll go over some other helpful Slurm commands that you might find useful. From there, we'll also talk about checkpointing, requeuing, and preemption, and job arrays and job dependencies. So let's first talk about what Slurm is. It's more than just a Futurama drink. It's actually a workload manager. This is Slurm's logo. And Slurm does a lot. In the context of this diagram, this is kind of how you might think about our systems. So you're over here with your computer, and you connect to our login nodes with SSH. Our login nodes do talk to Slurm, but Slurm is more managing our compute nodes to the right of the screen in this highlighted pink area over here. And Slurm will manage the time that's allocated on our compute nodes, the amount of CPU cores on our compute nodes that you have access to, the amount of GPUs that it will reserve for you, the amount of memory it'll allocate for you, and also it will manage access to certain QoSs. It stands for quality of service. Different QoSs reflect different ways we keep track of jobs and different ways they can be submitted. And in this lecture today, I'm just going to be talking about jobs as something super generic, just some unit of computation that you submit. Slurm will run jobs for you and will manage those, but we have to instruct it on how much time it'll take for that job, how much CPU cores that job will need, how much memory that job will need, that kind of thing. Slurm will do its best to schedule you in a fair way, allocate the resources you requested, and report back to you on the job status. That's just like a high-level overview about what Slurm does. So the way that most of you will be interacting with Slurm is with a command called sbatch. You'll probably write a job script, and so the example command here is just sbatch and then the name of your job script. Like I just mentioned, this is the recommended way to submit work to Slurm, and we highly encourage that all users use this method. The reason we recommend sbatch over other options is because sbatch is non-interactive. Other methods like salloc imply that there's a user sitting at their computer doing stuff in an interactive fashion. When you use sbatch, you don't have to wait on a user to do input, to type things, and so there's a lot more efficiency there. You will probably need to create a job script, though, to make everything automated and to spell out exactly what needs to happen in the job. We actually have a great job script generator up on our website that I'll demo here for you. And let me pull that up really quick. 1 second here. All right, if I switch which screen I'm sharing. There we go. So you can find our JavaScript generator here under documentation and then JavaScript generator. And it's something that's super cool to use. So you can just fill out this little form here with what you expect you'll need. So maybe you need 2 processor cores. So you could just change that to a 2. Maybe you need 1 GPU. And maybe you need like 16 gigabytes of memory and your job will be running for 8 hours. We can plug that all into the JavaScript generator here. And you'll notice down here, it'll populate all of this for us. So there are these comments here that are in place. So we can say, see that that 8-hour wall time has been put in here. The number of processor cores has been put in here. My GPU request has been put in there. And the amount of memory I'm requesting per CPU core has been put in here. So it's a super easy way to get an example script going. Of course, you will need to run your program and your code here, but that's going to be something that will vary depending on the research you're doing and depending on what programs you're using. Let's get back to the slideshow here. Cool. Let's see, there we go. Okay, so salloc is the other main way that you'll interact with Slurm. So here's an example command with salloc. Salloc does not have job scripts. So all of those comments in that job script, we actually need to pass in as command line flags. So you can see there that -n1 is asking for 1 CPU core with 1 task. That -t is asking for 3 hours. And I'm asking for 3 gigabytes of memory per CPU. Now I only have that 1 CPU, so I'll only get 3 gigabytes of memory in total. And then that -x11 flag is what enables using GUIs on compute nodes. That's usually something that we discourage. There's a lot of problems that can have, but it is useful to some of you. So know that that is an option, and that if you need help with that, you can always open a support ticket, shoot us an email, or come into our office hours so that we can assist you with that. Like I mentioned before, though, salloc is designed for interactive computing. So it is assuming that you're there at your keyboard ready to go when the resources get allocated. It's going to be assuming that you don't have a job script, that you're just going to be running commands from the command line there. But that if you are going to start up a GUI process, that -x11 flag will move that GUI so that it renders on your machine over your SSH connection, not on the supercomputer itself. So if there's no questions with that, I think we can move into some frequently asked questions. These are some really good questions that we get asked on a frequent basis. So I hope some of this is useful to you. One of the main questions we get asked is, how much memory will I need? And that's actually a really, really good question. It completely depends on the kind of software you're running. What we recommend is actually just making a guess. If you've been running a program on your laptop or on a desktop machine, you can use that as a basis. You can run it there and see how much it uses. If you find that your job is running out of memory, though, one thing that we recommend is just resubmitting it with twice as much memory as you requested previously, and repeating this doubling until your job completes successfully. From there, you can give yourself a slight buffer. Usually 20% is really good, just in case you use slightly more than expected in future jobs. Another question we get asked a lot is, will adding more cores to my job make things run faster? This is a good question because in theory, yes, adding more cores to your job can make things run faster. The trick is that the software needs to be implemented in a way where it can take advantage of those cores. In particular, your software needs to be multi-threaded. A little plug for our supercomputing class. If you end up taking that, you'll actually write some multi-threaded code and get a real deep dive into how that all works beyond what we can do in a short seminar lecture here. Another question that a lot of people ask is, will adding more nodes make things run faster? So if you remember, a node is basically a computer, and a computer can have several CPU cores. So not only can you add more CPU cores to your jobs, but you can actually add more than one node to your jobs. And the answer there is similar. In theory, yes, your job can run much more quickly if you're using multiple nodes. However, your code needs to be set up to do that. Usually, researchers use a programming framework called MPI to do that. There are some others called like OpenSHMEM. There's a few more, and they all handle the distributed computations there because you have to send messages back and forth between those computers. And another little plug for our supercomputing class, MPI code is actually something that's covered there. Now, there are a few other Slurm commands that we'll cover here that might be useful to you. One that is super handy that I use all the time is squeue. And there's a few different options there. The one I find myself using the most is -u with my net ID. It shows all the jobs that I have in queue, the ones that are currently running, the ones that are pending. You can also look at other jobs that are running in your research group with the -A flag. And in that case, you'll be using your sponsor's net ID instead of your net ID. And just like as if you were doing that -u flag, it'll show all of the jobs across your research group, all of the ones that are pending and the ones that are currently running. You can also look for a specific job if you have its job ID, and you can use the -j flag to do that. One concern that we do have, though, we have had some instances where users run squeue periodically every second or so, and squeue talks directly to Slurm to get the information that it needs. And running it constantly like that can actually lock up the database for other users, including Slurm itself. So if you need to monitor the queue, we recommend using watch-n60 or something like that. That -n60 says, please run that squeue-u my.nid command every 60 seconds. And that still gives you a pretty good feel of how your jobs are doing. It'll give you up to a minute resolution, but it will dramatically lower the amount of churn on Slurm's database there. Another helpful Slurm command is scancel. You can use scancel with the job's ID to cancel a job that's currently running or that's pending. In case, maybe you discover that there's an error with your job script, maybe there's some other reason to cancel it, maybe like running out of quota in some storage where your job's going to be writing to or something like that. Another potentially useful Slurm command is srun. For those of you who are familiar with MPI, you'll be familiar with the MPI run command, which is the launcher that'll kind of bootstrap MPI programs and set up all the communications. srun will actually wrap MPI run, and that can be helpful if you don't want to have to figure out the exact node list you should be using. srun can talk to Slurm, and it knows exactly the nodes and everything that's been allocated, and will set that up for you. You can actually also use it outside of a job. In that case, you'll need to make sure you're telling it the amount of time and the amount of memory and all of that. And srun will actually call sbatch and create a job for you. So that's something that can be super handy. I just saw a question from Jay. I don't know what semester the next supercomputing class will be held. That's a great question. I'm going to defer to maybe, I think Ryan is in chat. He might know, but he would have a better grasp on that than I do. Any other questions so far? Okay. Some other Slurm commands that might be helpful to you on top of the ones that we just discussed. saccount is something that can be super helpful. It tracks similar information that's available on our website for job statistics. You can use it to track CPU usage, memory used, all of that good stuff. It has so much information, though, that you actually have to tell it exactly what you want. So if you're interested in using that to track what's going on, we recommend looking at the manual page. You can run man saccount for the different metrics you can get. It's also very similar to another command called stat. Again, you can look at the manual page for that. They don't tend to be the hot commands that all our researchers use. Thanks, Ryan, for responding to Jay there. It looks like we don't have any guarantees, but we're definitely working on it. Scontrol is another command that might be useful. So scontrol will let you see the status of a bunch of different things in the cluster. It might be interested in a job, the state of a node, or an entire cluster of nodes, like a partition. And so you can use that to see what's going on there. There's also a bunch of different Slurm commands that I highly recommend taking a look at. There's saccount manager, there's sattach, sbcast, sinfo, sreport, and sshare. And you can look up all about them by running man and then the name of the command on one of our interactive nodes. Another super helpful thing that I want to make sure we cover today is job arrays. So let's imagine that I have an embarrassingly parallel problem. So I have this problem and I have a lot of chunks of work to do on this problem. Maybe it's I'm trying to optimize something and I have a bunch of different groups of parameters I want to iterate over. And so I'm going to be firing off a lot of jobs that look the same. They're going to have the same memory requirements. They're going to have the same wall time. They're going to have the same CPU allocations. And what we can do in this case is we can actually save Slurm a lot of work. We can say that we set this up as a job array, and Slurm will be able to reuse a lot of the computations to schedule you. This is actually only available with sbatch though, not salloc, because we're assuming here that you have a batch job you want to do. You've got a job script or something like that that can be automated. And so this is only going to work with sbatch, and it's not going to work with interactive computing with salloc. It's another reason that we highly recommend using sbatch. And when you do this, you can set the -a or -- array flags. They're synonyms for each other. The maximum number of array tasks we allow on our systems is about 5,000. And so you can see there's some examples. So I can say -- array equals 0, 6, 6 through 32. And that'll tell Slurm to fire off tasks 0, 16, 17, 18, all the way to 32 inclusive. You can also do some other cool stuff. For instance, in that second example, that 0-12:4 %2 is going to fire off every fourth task in that 0 to 12 range. So it'll do 0, 4, and 8. That's what that :4 is doing, is it's doing the count by 4. And then that %2 is going to only run a maximum of 2 of them simultaneously. So even though I have 3 tasks that'll fire off there, only 2 of them can run at the same time. Then there's another plug that I want to give here. One of our very own computational scientists, Michael Greenberg, has put together a really cool module called Slurm Auto Array. Its documentation is available on our website, and you'll be able to follow that link once we make our slides available. And Slurm Auto Array will help set up these arrays in a really easy manner. Highly recommend taking a look at it. If you do the route, though, where you're going to be doing your own job arrays, keep in mind that Slurm will set up these environment variables. So you can look at Slurm array job ID. That'll be the job ID for the entire array, because it's kept the same memory requirements, the same CPU requirements, and all of that. That'll actually be the same for the entire array. So you'll want to make sure you tune in especially to Slurm array task ID. That's the ID for the task that's currently running, just like what we saw in that previous slide there. If you're interested in doing some dynamic mapping of work to your array tasks, you can look at Slurm array task count, task max, and task min. They are exactly what they sound like: the total number of tasks in the array, the maximum task ID, and the minimum task ID. And one of the questions that sometimes comes up is, well, how do I fit all of my work into 5,000 jobs, or 5,000 array tasks, excuse me? And one way you can do that, especially if your unit of work is small, is by combining them into array tasks. So in here, I have just say 7 units of work, and keep in mind 7's a prime number, so it's not going to divide evenly. And we'll say here that each unit of work is something that's pretty bite-sized. It's something that maybe I can run in about 30 minutes or something. And so I want to combine them into slightly longer running array tasks. So I can set up my job script to do unit of work 1 and unit of work 2 in task 1, unit of work 3 and unit of work 4 in task 2, and then work 5 and 6 in task 3. And then keep in mind that even though task 4 will have the same wall time limit as 1, 2, and 3, it's just the way the cookie crumbles there with the division. And because it has at least the amount of wall time needed to run 2 of those pieces of work, it'll be fine with just that one piece of work for work 7 there. And so mathematically, you just want to do this with a little bit of multiplication and addition. So task 1 would get work 1 and work 2. So that's going to be, if you're doing 0-based indexing, and this would be ID 2, you just multiply by 2 and add the units of work there, and it all just kind of works out. Happy to answer any specific questions on that though. Cool. We'll move on to job dependencies here. So job dependencies is another really cool Slurm feature. Slurm will, if it's told, it actually won't start a job and schedule it until another job has met some condition. It's either started, it's completed with errors, or completed without errors. And so this makes it a really great technique. If I have this big job array where I'm doing this big parameter sweep or something, and I want to collect the results of all of those experiments and kind of clean up. And so I can tell Slurm, I have this big job array I want to run, and then I have this smaller job I want to run after all of the array tasks have completed. And there's some syntax examples I've given here. There's actually a lot that it can do though. So while I'm going to hit the highlights, I highly recommend looking up the manual page for sbatch because there's a lot more it can do. The one I imagine a lot of you will be doing though is using the after OK syntax. So you'll do a -d or a -- dependency. Those are synonyms. And in quotes, you could do after OK. So this next job will start after this job has exited with a good status. And I just hand it the job ID there where it says $job ID. Another one that might be interesting to some of you is the -- dependency singleton. It doesn't need to be in quotes because there's no colon in there. And so the singleton one will enforce that there's actually only one job that's running. It'll look at the job name and the user that's running that job to determine that. So it'll only schedule one of those for you. And that might be helpful if you're doing something where you're spawning a job to do some file IO or something and you don't want to overwhelm the system. So all of this array and dependency stuff can be really helpful as we talk about preempted jobs. So some research groups at BYU will purchase their own private hardware. We'll manage it for them at no charge. In return, they make that hardware available to our public users. So even if you're not part of these research groups, you can actually still run jobs on their hardware. The catch, though, is that your jobs need to be preemptible. Think about it like flying standby at an airline. A preemptible job can be terminated at any time and theoretically for any reason, but most of the time it's because a job from the hardware owner has a need for the resources that you're using. There's a slight grace period for cleanup. We'll talk about that in just a second. And because preemptible jobs can get canceled whenever, we need to usually use some method of checkpointing where we're saving work periodically, and so we can resume work based on some context. If you're interested in using a preemptible job, you can set the QoS to be standby, and that'll make sure that your jobs can be scheduled on that private hardware. If you're interested in having your job requeue automatically, if it's been preempted, you can use the -- requeue flag. Those will both get handed to sbatch there. A lot of programs, unfortunately, don't have automatic checkpointing functionality, which is a real shame. But there are some really good options if you need to add it after the fact. The one that we recommend for a lot of users is called Creue. There's others that are also good. And it's worth noting that some of the other options are better in other use cases. But Creue, even though it's not perfect, it usually covers a lot of our users' needs. Again, once we make these slides available afterwards, you can follow the links there to their website, and in particular to the what can't be checkpointed article that they have. And if you're using Creue, you'll need to do one of two things. The easy option is to dump context periodically. And that way, if you get preempted, you have hopefully some state that's been saved out, and you can check for it when you get requeued, and you can load it up and continue your job from where it left off. Another option is to catch a Unix signal called sigterm. It's a little bit technical. It's a little bit confusing since you have to know a little bit about how Unix is set up, but it works absolutely awesome if done right. And because this is something that's a little bit tricky to get set up, if you're interested in learning more about this, feel free to open up a support ticket and we can help get that set up for you. I think that's everything I wanted to cover about Slurm. If there's any questions about anything we've covered or any other supercomputing questions, feel free to ask yourself. And again, feel free to unmute yourself and ask verbally, or if there's anything in chat, we can address those as well.
Hey, Brennan, I got a question for you.
Absolutely.
With the dependency after OK flag, what job ID do you use for an array? So
great question. So I think I mentioned this. Let's see if I can scoot back in my slide here. So the job ID for the whole array will actually be the same for every array task. Because Slurm is reusing all the computation from what resources you'll need. So it's actually just that one job ID. If you look in your job stats or in other Slurm places, the way it'll show a job array is it'll be the job ID underscore array task ID. So you just use that normal job ID there.
Sure, thank
you. Any other questions from anyone? Cool. Well, since we don't seem to have any other questions, thanks for coming to this seminar. As always, feel free to open a support ticket or shoot us an email at rcsupport@byu.edu if you need to get in touch with us, or feel free to take advantage of our office hours. Thanks so much, everyone.